Thank you, everyone, and welcome to College Algebra. Today we'll be discussing section 3.1, which talks about quadratic functions. All right, so there is the standard form of a quadratic function that is given by, so the standard form of a quadratic function is given by f of x is equal to ax minus h squared plus k, where the a cannot be 0. The a is any number. We say this is in a vertex form. This is in a vertex form. When we write the standard form in this fashion, we say this is in a vertex form. It's in a vertex form. All right. If it's in the vertex form and the vertex point is the vertex form and the vertex points h, the x point of the vectors is h, and the y point of the vertex is k. And we also say that this function or parabola is symmetric. Is symmetric with respect to the line x is equal to h. So we call this the axis of symmetry. Axis of symmetry, or the line of symmetry, is x is equal to h. If the leading coefficient a is greater than 0, the parabola opens upward. Opens upward, which is of this form. And if a is less than 0, then the parabola opens downward. So it's a curve of such nature. Let's look at how to graph quadratic functions in vertex form. So the next thing we want to look at is graphing quadratic functions. Graphing quadratic functions with equations in vertex form. All right. Okay, so in a moment, when we open up one additional information, we will be Okay. Okay, let me pause this video a little bit and I will. Okay. All right, so to graph the function, um, so to graph the function, our goal is to graph a function of this form. To graph f of x is equal to ax minus h squared plus k, where the a is not equal to 0. If the a is equal to 0, it's no longer a quadratic equation. So the a cannot be equal to 0. So the a cannot be equal to 0. All right, so these are the steps that we take. So first of all, we have to determine whether a is greater than 0 or less than 0. If we know a is greater than 0, then we know that the function opens upward. If we know a is less than 0, if we know a is less than 0, then we know the function opens downward. The next thing, we also have to determine the vertex points. We have to determine the vertex points. The vertex points are for the curve that opens downward is the highest point, and the curve that opens upward is the lowest point. So the vertex points. The vertex points H in there a pair of points. H, so we have to determine that. And the next is we have to find the F. We have to find the x-intercept. We have to find the x-intercept, which means we have to set the function equal to 0 and then solve for uh, we have to set f of x is equal to 0 and solve for the x values to determine the x-intercepts. Okay. All right. So the next, let me write that down. So the next thing we have to do is we have to find the x-intercepts. And to find the x-intercepts, it just means we have to set the function for x is equal to 0 and solve for the values of x. So for the values of x. And the next we also have to find the y-intercepts. Find the y-intercepts by computing f of 0. To find the y-intercept, we set x is equal to 0 and we solve for y. All right. And the last thing is we plot the intercepts, the vertex points, and any additional points. So the last thing is we'll plot the x and y intercepts. The vertex points and any additional points. All right, so we will do this. So these are the steps that we take to be able to graph a quadratic function. Okay. All right, so let's pick an example to go through this. So example one. This is graph the quadratic function of the quadratic function f of x is equal to negative x minus 1 squared plus 4. All right, so we'll go through the steps. The first thing is to check whether a is greater than 0 or less than 0. So if we compare this to the standard form, ax minus h squared plus k, we can see that a is equal to negative 1. Um, a is equal to negative 1, which means it is less than 0, so the curve opens downward. So we know the curve opens downward. The next thing is we have to find the vertex points. The vertex points are h and k. And so if we compare this standard form to this, we can see that h h is negative, h is 1, and if you compare is 4. So these are the vertex points by comparing the standard form to um, the given example. All right, so the next thing is we find the x-intercepts by setting f of x is equal to 0. So to solving, so to find the x-intercept, we set f of x is equal to 0. So that means we have minus x minus 1 squared plus 4 is equal to 0. So minus x minus 1 squared is equal to, if we subtract 4 of both sides, we get negative 4. So if we divide now, negative 1 on both sides, we have x minus 1 squared is equal to 4. And now we take square root on both sides. And if we take square root on both sides, then we get x minus 1 is equal to the plus or minus square root of 4, this plus or minus 2. So that means x minus 1 is equal to plus or minus 2. So x is equal to 1 plus or minus 2. So that means x is equal to 1 plus 2, which equals to 3. 1 minus 2, which equals to negative 1. So we find the x-intercepts as uh, the x-intercept points will be um, 3, 0, and -1. Remember, we said f of x is equal to 0. So at the x-intercept, the y values are all 0. So we have two x values, and each of them has a y value of 0. Okay, then let's find the y-intercepts. So the y-intercepts. So the y-intercept, we set s is equal to 0 and off for y. So y-intercepts x is equal to 0. So we have f of 0, which is equal to -0 minus 1 squared plus 4. And this equals to -1 plus 4. And this equals to 3. So the y-intercept x is equal to 0. So we have the pair of points 0 and 3. All right, so now we have a pair of points that we can use to graph our function now. So let's try to graph our function now. All right, so 1, 2, 3, 4, 5. So this is x. That is 1, 2, 3, 4, 5. And this is -1, -2, -3, -4, -5, -6. This is 1, 2, 4, 5. All right, so the vertex points are 1 and 4. So 1 and 4 is around here. So these are vertex points. The intercepts are 3 and 0. So 3 and 0. And the other one is -1 and 0. So -1 and 0. So this vertex point is 1 and 4. This is 3 and 0. This is -1 and 0. And the other point is the y-intercept, which is 0 and -3. So 0 and +3, rather. All right, so now we have this pair of points, and so now we can join all of them to get our function. So with this pair of points, we're able to graph our function. And the axis of symmetry is the line equal to 1. It passes through, it's a vertical line through the vertex. So we can also graph that as be a straight line through 1. So this is the line x is equal is the axis of symmetry or symmetry line. So this is the equation of symmetry. The equation of symmetry. All right, so let's go on. Um, so we've looked at the vertex whose form which is of the form ax minus h squared plus k. Let's also look at another quadratic function whose equation is the vertex of a parabola, whose equation is f of x. Let's write this as f of x is equal to ax squared plus bx plus c. Let's look at how we find the vertex of such functions and how we graph it. When a quadratic function is given this way, so one, if you want to graph it, we have to determine whether a is less than 0 or a is greater than 0. If a is less than 0, then we know the parabola opens downward. If it is greater than 0, then we know uh, if we know the parabola um, opens upward, and if it's less than 0, we know it opens downward. And we have to determine the vertex points. We determine the vertex points using the formula minus b divided by 2a and f of minus b divided by 2a. So this is how this is the formula that we use to determine the vertex points, and next we'll find the x-intercepts. Which is obtained by solving f of x is equal to 0 and solve for x. F of x equal to 0 and we solve for x. And the next thing is we find the y-intercepts by substituting 0 for x, by substituting 0 for x. All right, so let's use an example to go through some of these steps. So this will be our example 2. And it says graph the function minus x squared plus 4x plus 1. Use the graph to identify the functions domain. And all right. So the first thing, if we compare minus x squared plus 4x plus 1 to the standard form ax squared plus bx plus 1. If we compare this to this, then we can see that A is equal to -1, B is equal to 4, and C is equal to A is equal to -1, B is equal to 4, and C is equal to 1. So we know that from here, we know that A is less than 0, is -1, so less than 0, so the function opens downward. You know that the curve is going to open downward. And the next thing, let's find the vertex. So the vertex is minus b divided by 2a, and f of minus b divided by 2a. So minus b divided by 2a is equal to minus b, so -4 divided by 2 times a, so 2 times -1. So we have -4 divided by -2, which is +2. And so f of minus b divided by 2a is equal to um, f of 2, which is -2 squared plus 4 times 2 plus 1. And this gives us -4 plus +8, which is 3 plus, -4 minus 2 squared is -4 plus 4 times 2, which is 8. So that is 4 plus 1. So this is 5. All right. So let's find the x-intercepts. So to find the x-intercepts, we said f of x is equal to 0, and we solve for x. So we were solving the equation minus x squared plus 4x plus 1 is equal to 0. All right, so we can use the quadratic formula to solve this. So quadratic formula, x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a is equal to -4 plus or minus 4 squared minus 4 times -1 times +1 divided by 2 times -1. And so this is equal to -4 plus or minus square root of 4 squared, which is 16, plus 4 times -1 times 1 is +4 divided by -2. So this is equal to -4 plus or minus square root of 20 divided by -2. So x is equal to -4 plus square root of 20 divided by -2, which is approximately -0.2, and x is also equal to -4 minus square root of 20 divided by -2, which is approximately 4.2 if we find this on our calculator. So the parabola crosses the x-axis at these points. It, so, it, 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 it crosses the x-axis at this point, minus 0.2, and the y value is 0, and 4.2 and 0. So these are the x-intercepts. Okay, so next let's find the y-intercepts. So the y-intercepts, we set 0. So that would be f of 0 is equal to minus 0 squared plus 4 times 0 plus 1, and this equals to 1. So the y-intercept points are 0 and 1. All right, so we have all these points now, so we can plot our parabola now. All right, so the vertex points are 2 and 5. So the vertex points are 2 and 5. The x-intercepts are negative 0.2 and 0. And the other one is 4.2 and 0. So 4.2 and 0 is also about here. And the y-intercept point is 0 and 1. So the y-intercept this point here. All right, so we have this pair of points, so we can begin to parabola through it. Um, so this is our parabola, and the axis of symmetry goes to x is equal to 1, x is equal to 2, x rather, so that it goes to the vertex points. X is equal to 2 is our axis of symmetry. All right, so this is how we graph this, and from this function, we can determine the domain and the range. We can see that the domain is over all x values, so the domain is from minus infinity to positive infinity. And we can see that the range goes from this point here and goes downward. So the maximum point that this function value can be is 2, is 5 rather, is 5. and it goes all the way down. So the range is from minus infinity to the maximum point it can be, which is 5. The function cannot be larger than 5. 5 is its maximum. So it's 5 or less. That's the range can be 5 or less. All right. So let's look at minimum and maximum quadratic functions. So minimum and maximum quadratic functions. Maximum quadratic functions. All right. So if a is greater than 0, function has a minimum. The function f has a minimum that occurs at x is equal to minus b divided by 2a, and the minimum value is f of minus b over 2a. And if a is less than 0, then f has a maximum f of minus b divided by 2a. And this maximum value occurs at x is equal to minus b divided by 2. Right. So let's use an example to explain this. So the example is this we call example 3a. 3a, we say consider a quadratic function. Consider the quadratic function f of s is equal to minus 4x minus 16x plus 1000. Determine without graphing. Determine without graphing. Determine without graphing whether the function has a minimum or a maximum. All right, so first of all, because a is less than a here is 4, b is negative 16, and c is equal to 1000. So since a is less than uh, which 4 is less than 0, this function has a maximum function. The function has a maximum. Has a maximum value. All right. Let's look at another example. So this will be example 3B. Example 3B. It says, consider the quadratic function. Consider the quadratic function. F of x is equal to negative 4x squared minus 16x plus 1000. Find the minimum. Find the minimum or maximum value. Maximum value and determine where it occurs. Determine where it occurs. So given this function, we can see that a is equal to negative 4, b is equal to negative 16, and c is equal to 1000. All right, so the maximum occurs at the so because a is less than 0, which is less than 0, it has a maximum value. The function has a maximum value. And this occurs at the vertex, so we need to find the vertex point. So the maximum occurs at the vertex. The maximum or minimum always occurs at the vertex. So since this is a maximum point, this the maximum will, so the vertex points, the x part is or let me write it as h is equal to minus b divided by 2a, which is equal to minus negative 16 divided by 2a, which is 2 times negative 4. So this becomes negative times negative 16, positive 16 divided by 2 times negative 4, which is negative 8. So this becomes negative 2. And so the k part is equal to f of minus b divided by 2a, which is f of negative 2, which equals to negative 4 times negative 2 squared minus 16 times negative 2, and this plus 1000. So this gives us negative 16 negative 16 and minus, um, let's say, so this gives us maximum occurs at x is equal to -2. So this gives us um, minus 2 squared is positive 4 times -4 is -16. Minus 16 times minus 2 is positive 32. And plus this plus 1000. And so this equals to um, let me see if I made any mistake here. So -4. First of all, h is -2, which is -16 divided by uh, -h and -2. So -4 times -2 squared, which is 16, -16 minus minus -16 plus this. So yeah, so this becomes 1000 plus 1000 plus 16. So it's 1016 becomes the maximum value, becomes the maximum value of f. So this is the maximum value. This is the maximum value of f. All right, so let's look at another example. So this is example 3c, and it says f of x is equal to, uh, okay, so the same example that we just saw for x squared minus 16x plus 1000, and we have to identify, let's see, we have to identify the domain, identify the function's domain and range. All right. All right, let me go back here. Let me check one more thing to see everything was, there's no mistake anywhere. Um, okay. All right. So the functions domain, so this is a quadratic function. So its domain is from minus infinity to positive infinity. And its range, since this is a maximum curve, so it's a curve that goes down like this. Well. So this is a maximum curve, so it goes, it's a curve that opens downward, and the vertex points here we found to be -2 and 1016. So the range goes from this point downwards. So the maximum range of the maximum range of the function is 1016, and it goes all the way to minus infinity. So it's going all the way from the maximum point downwards. So the maximum it can be is 1016, and and the and the and yeah, so it goes from its maximum value of 1016 all the way down to negative infinity. So this should be the domain. And its maximum occurs at these points. Its maximum occurs at these points. The maximum point always occurs at the vectors. All right, so let's look at another example. So this should be our example 4. Should be our example 4, and it says, example 4, and it says, maximizing area. So this has to do with maximizing area. So it says, you have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the inclusive. What is the maximum area? All right, so we have a rectangle which has length L and the width W, and we have to find 120 feet, and we have to find the dimensions that maximize the area first. So we know the area A of a rectangle is the length times the width, and we know that the perimeter, or the amount of fencing that we have to do, is 2L plus L, which is 2L, plus W, which is 2W, and this equals to 120. So from here, we can solve for L. So 2L is 120 minus 2W. So we divide 2 by 2, and we find that L is equal to 60 minus W. L is equal to 60 minus W. So the area is length times the width. So area is the length times the width. So the area is the length, which is 60 minus W times W, which is 60 W minus W squared. So the dimension that maximizes the area occurs at the, we have to find the maximum of this area, or the vertex points. And so since A is less than 0, if you compare this to the standard form of a quadratic equation, um, A is equal to -1, and this is less than 0, so the function has a maximum. So the area has a maximum at has a maximum at um, minus b divided by 2a, which equals to negative 60 divided by 2 times negative 1, which is equal to 30. So the width that gives us the maximum area is 30, and the length is equal to 60 minus W. So the length that will give us the maximum area will also be equal to 60 minus 30, which is also 30. So the maximum area becomes is the length times the width, which equals to 30 times 30, which equals to 900. Okay. Let's look at another example. So let's call this example 2b, and it says find the vertex for the parabola. Find the vertex for the parabola defined by the quadratic function. F of x is equal to negative x squared plus 10x plus 9. All right, so to find the vertex, the h is f of minus b divided by 2a. So this is equal to no, h is just equal to minus b divided by 2a, and this is equal to minus b. So minus b, so b is 10, so 10 divided by 2 times a is negative 1. So this becomes negative 10 divided by negative 2, which is 5. And k is equal to f of minus b divided by 2a, so which is f of 5. And this equals to um, minus 5 squared plus 10 times 5 plus 9. And this gives us 34. So this becomes the vertex point. All right. Let's look at another example 2C. We call this example 2C. And it says find the vertex. No, it says write the equation of the following parabola in vertex form. Write the equation of the following parabola in vertex form. The vertex following the vertex points are vectors is negative 4, -3, and the graph passes through the points. The graph passes through the point 2, 9. All right, so the standard form of the quadratic equation in the vertex form is equal to f of x is equal to ax minus h squared plus k. So if we compare this to the vertex that we have been given, so a is -4. H is -4, so this equals to a, and so the vertex form from the standard form, the vertex is hk. So if we compare this to the vertex that we've been given, which is -4, -3, this standard form, we can write it as a and x minus h, which is -4, and squared plus k, and k is -3, so -3 here. And so we have f of x is equal to x minus -4 is plus, so x plus 4 squared minus 3. All right, so we have this. And we are told that the points, we are told that the graph passes through the points 2, 9. And since we know that the vertex, so we are told the function also passes through the point 2, 9. All right, so with that, what that tells us is that the point 2, 9 is above the vertex because f of x opens upward. F of x opens because we are told the point 2, 9, the graph passes to the point 2, 9. The point 2, 9 is above the vertex point. The point 2, 9 is above the vertex. Let me write it down. Which implies f of x opens upward. All right, so to find a, we can find a by, well, let's go ahead and find a. So to find a, we can set the y value. So to find a, we can set the y value equal to 9 and the x value equal to 2. So f of x is equal to ax plus 4 minus 3. And we know f of x passes through the points 2, 9. X is 2 and y is 9. So if we replace f of x by the y point, so 9 is equal to a times x, which is 2, plus 4 minus 3. And so 9 is equal to a, 2 plus 4 is 6. So 6 and the squared, forgot about the squared here. So 6, 2 plus 4 is 6, so 6 squared is 36. So 36a minus 3. And so if we add 3 on both sides, then 12 is equal to 36a. 12 is equal to 36a. So we divide both sides by 36. and that gives us a is equal to 1/3. So f of x is equal to 1/3 x plus 4 minus 3. All right, so this is how we find the equation of the this is how we find the equation of um, f of x when we are given the vertex and the point it passes through. All right, so last example, let's look at this example 4b, and it says a ball is thrown upward and outward from a height of 7 feet, from a height of from a height of um, this a ball is thrown upward and upward from a height um, from a height of a certain feet, and the height of the ball f of x in feet can be modeled by f of x is equal to negative 0.1 x squared plus 0.7 x plus 5, where x is the ball's distance in feet from where it was thrown. Use this to solve A. What is the maximum height? What is the maximum height of the ball, and how far from where it was thrown? And B, how far does the ball travel? Does the ball travel horizontally far does the ball travel horizontally before hitting the ground? And C, all right, so Let's try to solve these two. So A, we know that the maximum would occur at the vertex point. The maximum, so for A, we know that the maximum height, occurs at the vertex point. So the maximum height and how far it was. The maximum point and how far it was shown uh, will be the vertex point. All right, so the vertex point H is minus B divided by 2A, which is equal to negative 0.7 divided by 2 times negative 0.1, which is negative 0.7 divided by negative 0.2, which is equal to 3.5 feet. And A, the maximum height is equal to f of minus b divided by 2a, which is f of 3.5, which is equal to minus 0.1 times 3.5 squared plus 0.7 times 3.5 plus 5 equals to 6.225. So the maximum height is 6.22. So the maximum height is equal to 6.2225 feet. And this occurs at the distance of about 3.5 feet. And B says find, B said, how far does the ball travel horizontally before hitting the ground? So when the ball hits the ground, at the time the ball hits the ground, its height is 0. When the ball hits the ground, f of x is equal to 0. Height is 0. So that's what this statement means. F of x is equal to 0, or which means the same thing as the height at that point equals to 0. So that means we have to solve the function for h0. So that means f of x is equal to 0. So that means negative 0.1 x squared plus 0.7x plus 5 is equal to 0. So let's use the quadratic function to solve for x value. So quadratic function minus b plus or minus b squared minus 4ac divided by 2a is equal to negative 0.7 plus or minus square root of b squared, which is 0.7 squared minus 4 times a, which is negative 0.1 times c, which is 5. All this divided by 2a, which is 2 times negative 0.1. And so this equals to minus 0.7 plus or minus square root of 0.49 plus 22 all divided by minus 0.2. So this equals to minus 0.7 plus or minus square root of 2.49 divided by negative 0.2, and this equals to negative 0.7 plus or minus 1.578 divided by negative 0.2. So this equals to negative 0.7 plus 1.578 divided by 2, or negative 0.7 minus 1.578 divided by 2. And if we evaluate this, we get minus 4.39 and 11.39. But we are looking for time when the ball, what we are looking for is when, so B, we were asked to find how far the ball travels horizontally before hitting the ground. And so that means the ball traveled nearly 11.4 feet. The negative will not be of use here. So B, what we take as the distance that the ball traveled before hitting the ground is 11.39, since the negative distance is not possible. All right, so this brings us to the end of section 3.1, and we will end here and we'll continue on the next one.